Look down at your feet for a moment. Chances are you are standing on it right now. It is in your walls, your driveway, the bridge you crossed this morning, the sidewalk outside every coffee shop, school, and hospital on the planet. We are surrounded by it, but almost nobody knows how it is actually made. Concrete gets all the credit, but concrete is just the finished product. The real magic is in the ingredient that holds everything together: cement, a gray powder that, when mixed with water, transforms into one of the strongest materials human beings have ever created. And the process that makes it happens inside a machine the size of a skyscraper at temperatures hot enough to melt aluminium. So where does cement actually come from? It starts in the ground. Cement is made primarily from limestone, that is calcium carbonate, the same mineral that makes up seashells, chalk, and coral reefs. Limestone is quarried in enormous open pits, blasted loose from the earth in huge chunks, and then crushed down into smaller and smaller pieces using giant mechanical jaws and rollers until it becomes a fine powder. But raw limestone powder on its own is not cement. Not yet. To turn it into something useful, you have to change it at a chemical level, and that requires heat. Enormous, almost unimaginable heat. The powder is fed into what is called a rotary kiln. Picture a hollow steel cylinder about the length of a football field, tilted at a slight angle and slowly rotating. The inside is lined with heat-resistant bricks, and at one end a flame burns continuously, fueled by coal or gas. The temperature inside reaches around 1,450 degrees Celsius. That is hot enough to melt lead more than 3 times over. Here is where the chemistry gets interesting. As the limestone powder slowly travels down the length of the rotating kiln, the heat begins to break it apart. Carbon dioxide is driven out of the calcium carbonate, releasing it as a gas. What remains is a new compound called calcium oxide, quicklime. The material has been chemically transformed. It is no longer just crushed rock. It is something entirely different. Near the hottest zone of the kiln, the calcium oxide reacts with other minerals in the mix, things like silica, alumina, and iron oxide. These are usually added from clay or shale. Under extreme heat, they fuse together and form small dark nodules called clinker, little rocky lumps about the size of marbles. This is the heart of cement. Clinker is what everything has been building toward. The clinker drops out of the kiln and is rapidly cooled using blasts of air. Cooling it quickly locks in the chemical structure that makes cement work. If it cooled too slowly, the compounds would reorganize, and the final product would be weaker. Now comes the last step. The cooled clinker is ground down again, this time into an incredibly fine gray powder. A small amount of gypsum is added during this grinding stage. Gypsum is the same material used in drywall and plaster of Paris. Its job is to control how quickly the cement sets when water is added later. Without it, cement would harden almost instantly and be nearly impossible to work with. That powder is cement. When you add water to cement, you are not just making it wet. You are triggering a chemical reaction called hydration. The compounds in the powder react with the water molecules and begin forming new crystalline structures, tiny interlocking needles of calcium silicate hydrate that grow and bond and harden over time. The cement is not drying out, it is actually growing stronger from the inside. This is why freshly poured concrete feels soft and workable at first, then slowly stiffens over hours, and then continues to gain strength over weeks and even months. The reaction does not stop quickly, it just slows down. Old concrete is often stronger than new concrete, not weaker. The Romans figured out a version of this over 2,000 years ago. They mixed volcanic ash with lime and seawater and built structures that have survived earthquakes, floods, and 2 millennia of time. The Pantheon in Rome, still standing, still intact, was built using a form of ancient cement. Modern engineers are still studying exactly why it has lasted so long. So the next time you walk past a construction site or drive over a bridge or lean against a wall, think about what is holding it all together. Limestone pulled from the ground, crushed, heated to extremes, chemically transformed, ground back to powder, and then reborn through water into something almost permanent, a gray powder that quietly holds the modern world together. If you enjoyed this video, hit the like button and subscribe to Simple Concepts Explained for more stories about the everyday things we never stop to think about. See you in the next one.